All right, guys, this is the brand new. We're gonna do these videos over again. Okay. And so right now it's that video. I don't even know what it is, from 2 years ago. So this one's for you, Math 86. We're gonna do number of solutions, the challenge, sum of consecutive numbers, and then I know I don't have a link there, but I'll show you what that solving equations interleaved practices. So get your pencil, your paper, and be ready. Take notes. Ready? We're just gonna do like first problem in each one, and this way I don't have to say the same things in class. Okay? How many solutions does the following equation have? So first of all, before we even answer that question, you should notice on this side something special. The parentheses. How many people notice that? That means this parentheses means we're gonna need to distribute, right? So I'm gonna need you to distribute. I'm gonna need you to write down this equation and write down the word distribute. Everything I write down, you need to have in it, okay? And now let's do it. You can even pause the video, distribute, write the new equation, and then start the video. If you do that, you'll learn how to do it. All right, on pausing, hopefully, I'm going to distribute that 4, so I get 4y minus 4 times 3 is 12, so that's going to be 120. And then we're just going to write this side over again, equals 4y plus 12. Now, you should notice, that we have two variable terms, right here and right here. But they are the same. So draw an arrow to those and write same. And whenever that happens, the answer is not one solution. So because variable terms are the same on different sides. All right. I know this is very hard to read, but it's okay. Because variable terms are the same on different sides. Okay, whenever that happens, there is not one solution. If they were different, there would be one solution and we could cross off the other two. But because they're the same, there is either no solution or infinitely many solutions. Well, how do we know the difference? Well, cross these variable terms off since they're the same. And what would be left? Just write that. What would be left on the left side? If the 4y isn't there, we would just have negative 120. See? And what would be left on the right side? I keep getting all these colors. Okay. We would have 12. So now look, is negative 120 equal to 12? The answer is no. So we're going to write not true. And whenever it's not true, that means there is no solution. We're just going to go ahead and click on no solution, and you will see that I am right. Ta-da! See? All right, so that was your no solution example. Now let's clear all drawings. Okay, so now let's do this one. So again, it's not like you're going to have to distribute every time, but here we see distributing again. So we have negative 14z minus what is, so 5 times 14, I'm going to do that over to the side. So 5 times 4 is 20. 5 times 1 is 5 plus 2 is 70. Perfect. Okay. And then the negative times the negative is positive 70. So that's that side. And then this side right here, I'm just gonna rewrite that over there. It's gonna be. All right, so now we notice our variable terms are the same again. And this time, our constant terms are also the same. So in essence, the variable terms cross off, and then we would be left with 70 equals 70. This time, that is true. Oh, and by the way, I hope you crossed off negative or one solution because we know when the variable terms are the same. It's not that. You should have that in your notes from the first problem. And now, because this is true, so we're going to write true. And when it's true, that means there's not no solutions because that happens when it's not true. So I'm just going to click on infinitely many solutions. You see? So you can just make a little organizer here. Okay. Let me just share a new share. We're going to just share the whiteboard here. Okay. So this is the idea. We have 3 cases. Wow, look at that. So one solution, infinite, and no solution. So this is how many solutions there are. There could be one solution, and that happens if variable coefficients are different. And then in both of these other ones, in the infinite solutions, the variable coefficients are the same, and also the constants are also the same. That is the infinite solution. And then no solution was when those variable coefficients were the same, but the constants, what were they? You know, they were different. All right, so we're gonna do the challenge exercise now. And if we see, the first thing I'm gonna look at is those variable coefficients. And if they're different, then I know the answer is one solution. I don't even need to solve it. But if the variable coefficients are the same, then I'm gonna look at the constant terms. And if the constant terms are also the same, I know there's infinitely many solutions. And if the constant terms are different, I know there is no solution. All right, so let me show you that. So I'm going to do the challenge, and it'll be easy because if you try to solve all of these, then it's going to take a long time. So let's look at it. You see the variables are the same, and we also see the constants are the same. So that means infinite solutions. So A has infinite solutions. In B, the variables are the same, and the constants are the same. So B has infinite solutions. In C, same thing, everything's the same, infinite solutions. And in D, same. That's crazy. That's crazy. What a question. They are just all the same. So I'm checking them all. Let's find one that's different. Okay. So in this one, what have we got? Okay. Same. So we know that. In B, the variable coefficients are different, so it's not that one. And in C, the constants are different, so it's not that one. Oh, I'm sorry. I forgot to read the directions. And I hope you don't forget to read the directions. Okay, so which of the following have one solution? That's when the variable coefficients are different. So this one, the variable coefficients are not the same, they're opposites. In all the rest, the variable coefficients are exactly the same. So they have either infinite or one solution. Let me just. This one would be no solutions because those constants are different. This one would be no solutions because these constants are different. This one is one solution. And this one would be infinite. Infinite. Okay. So I hope that's helpful for those two. Now we are going to do the next exercise. So if you want to, you can try those two assignments and see if you can get them to 100. Make sure you post in the organizer. And now we're going to go on to something new. Are you ready? All right, sum of consecutive integers. There's two kinds, okay? The sum of consecutive integers and sum of consecutive odd/even integers. We're going to do both of them to get you ready. The sum of 6 consecutive even integers. Okay, so that means even means 2, 4, 6, 8, on and on, skipping the odd. So 6 of those guys equal 270, and we don't know which ones they are. But so we'll call the first one X. And we know if we add 6 of these even integers, then they will add to 270. So the next integer would have to be, we're going to call it X plus 2, because X plus 1 would be the very next number. X plus 2 is going to be 2 numbers later, which is the next even number. Notice to get from 2 to 4, you have to add 2. To get from 4 to 6, you have to add 2. To get from 6 to 8, you have to add 2. So to get from even number to even number, you have to add 2. And guess what? Even with the odd numbers, guess how much you have to add? 2, okay? So whether it's even or odd, we're always adding 2 to get to the next number. If we see consecutive even or odd. If we see just plain old consecutive, then like 1, 2, 3, 4, 5, it could have just asked us for consecutive numbers. In that case, we just add 1 to get to the next. That's a different problem. So this one, we're adding 6 numbers together. So watch this. There's my third number. There's my fourth number. How many numbers I got? 1, 2, 3, 4, 5. And now I gotta add. A lot of numbers, okay, but do you see all 6 numbers? 1, 2, 3, 4, 5, 6. So how many x's do I have? I have 6 x's. So I'm just going to combine those. And how much is 2 plus 4 plus 6 plus 8 plus 10? Go ahead and do that. 2 plus 4 is 6. And then 6, so that's 6. 6 plus 6, 12. 12 plus 8 is 20. 20 plus 10 is 30. So it's going to be, just did that in the head. 6x plus 30 equals 270. Now let's subtract 30 from both sides. 240 equals 6x. Divide. X equals 40. Is that right? So that means the first number in the series is 40. The second number would be 42 because these are even numbers. 44, 46, 48, 1, 2, 3, 4, 5, and 50. So these are the 6 consecutive numbers that when you add them together, you get 270, okay? And so the question says, what is the second number in the sequence? That would be good old 42. So you can rewind that and watch me do that as many times as you need to until you feel really comfortable. But we're going to do one more. And then that's all the problems I need to do for this week. Oh, okay. Okay, so this is the second consecutive odd number, so I'm just gonna skip past that. It would be the same. We would do x plus 2, x plus 4 equals 51. And so you can try that. Okay, this is odd numbers again. So I want to see one that doesn't say even or odd. Because if it says even or odd, it would just be the same as what I just did. But all of these say even and odd. They just all said even and odd. That's okay. Let's just try that. Okay. Going back to Mr. Tillman, sum of consecutive numbers. Let me just pause this really quick. Well, look at that. I found one. So this one says the sum of 5 consecutive integers. Okay, so now we're going to do x plus 1 plus x plus 2 plus x plus 3 plus x plus 4, and they all equal 265. Okay, so there's our 5 numbers. 1, 2, 3, 4, 5. How many x's do we have? 5 x. So however many numbers there are, that's your coefficient for x. And then add those constants together. 1 plus 2 is 3. 3 plus 3 is 6. 6 plus 4 is 10. And then solve the two-step equation. Subtract 10 from both sides. 5x equals 255 divided by 5. And x divided by 255. I don't know what that is, so I'm going to do some work over to the side. And then 5 goes into 5 times. And then one more time, I guess. So 51. So it says, what's the fifth number in this sequence? 51, 52, 53, 54, 55. 1, 2, 3, 4, 5. So I guess if I didn't do any math wrong, the fifth number would be 55. Let's see. If I get it wrong, yeah. All right. So those are the new concepts for this. And the last assignment for this week says interleaved practice. And so I'm not going to do that one. I just want to show you about that. So this is quiz 1 from solving equations. Later in the course, you'll have the solving equations unit test. But this week, I just want to show you, this is solving equations with variables on both sides and fractions, right? So we see that. All right, solving equations with decimals. We see that. Here's the decimals again. And then this one is the distributive property. So remember, those are 2 different assignments, but here it's putting it all together. And here is fraction again. And so you got to think a little bit harder. I didn't, because it just kept running through it. But they're going to put all the different solving equations assignments together. And so that is called interleaved practice, when the problems look the same, but they require different strategies. That makes your brain work even harder, but it will also make you remember it, which is what we want, right? Okay, so when I ask you to solve equations in the winter, even though it's the end of October here, and it will have been a couple months gone by, you'll still be able to do it because you're doing that interleaved practice. Okay, so do the best that you can. Post your problems in the organizer. We'll get it in class as well. Bye for now.